All right, so today for this video, we're going to look at how we make a probability table. So probability tables, they could show all the outcomes when there are two events. So if I want to know the probability of flipping heads on a coin and rolling a 5 on a die, or if I want to know the probability of wearing a blue hat and red shoes. So a lot of times they'll be used for and probability. So like when you're asking for the probability of one event and another. And the inside of the table shows all the combinations of the two events. But we'll look at it. I think that'll make more sense when you see a table. So here's the first example for you. I said Frank is buying a birthday cake. He can choose between 3 cake flavors, vanilla, chocolate, or carrot, and 2 icing flavors, strawberry, blueberry, or strawberry and blueberry. How many combinations of 1 cake flavor and 1 icing can he make? So I actually didn't even ask this one as a probability question. What you would be asked then later would be like, what is the probability that he will pick strawberry and chocolate? But let's just look at how we see all the outcomes here. So I drew just a blank table. And what you want to have is you want one of the events. So in this case, the 2 events are the choice of cake and the choice of icing. One of the events is going to go on the outside of your table on the top. The other is going to go on the outside over here on the side. And you're going to list the different outcomes for those events. So for the cake flavors, there were 3 flavors. There was vanilla. I was trying to leave 6, 1, 2, 3, 4, 5, 6. Okay. And then there was chocolate. And then of course there was carrot. Goes right here. So all I'm doing right now is I just listed the different choices that we had there for cake flavors. Then I'm gonna go put the icing flavors over here on the side. So 1, 2, 3, 4, 5, 6. So there's one right there. And what are the options? Strawberry. I'm going to write them this way just so you can read them in the video. And blueberry. So my table is going to come from splitting up into these pieces based on the events on the outside. So like we split it in half for the strawberry and the blueberry. And then we're going to split it into thirds. Now I did mine so that it was actually drawn to scale, like where it's actually split into thirds. When you're drawing a probability table, it doesn't need to be perfect like that. It just has to have the right amount of spaces. So where we see our combinations of cake and icing are in the inside. So you can abbreviate when you do this stuff. It makes your life a little easier. But this one right here, this would be a vanilla cake with strawberry. But if you wanted to just write like VS, that would be fine. This would represent a chocolate cake with strawberry. This would be for carrot cake with strawberry. And then down here, we're gonna do all those combinations, but with blueberry. So I could also get a vanilla cake with blueberry, a chocolate cake with blueberry, and the last one over here would be a carrot cake. Oops, with blueberry. So here we can see all the combinations that we have. So there's actually 6 total combinations. And what else do I want you to notice here? I want you to notice that if you look at this line, these are all strawberry cakes, but with the 3 different, strawberry icings, but with 3 different flavors of cake. And if you look this way, it's gonna cover the, like these are both vanilla, but it shows the 2 different options of icing. So if we wanted now to find the probability of one of these, so like if I said, assuming he's picking it randomly, what's the probability he'll get vanilla and blueberry? I'm really abbreviating that there. So probability, vanilla, blueberry. We know that probability is the number of desired outcomes divided by the total number of outcomes. So vanilla blueberry is 1 cake here out of 6. So it'd be 1 cake divided by the 6 total combinations, and there's a 1/6 chance. If I asked you a question like, what's the probability he will not pick carrot cake? Well, we know that not something is the same as all the other outcomes other than that, right? So we have carrot cake and strawberry, carrot cake and blueberry. There's 2 of them. That means that there's 4 options that are not carrot cake. And again, it's still out of 6, so it'd be 4 out of 6. Which actually simplifies to 2/3. Okay, now let's see another one. This one's pretty common. Is a pretty common use for a probability table. The first time I ever saw this was in a book about strategy for playing Monopoly, and they were talking about why certain numbers come up more when you roll 2 dice. So I made a really bad start of this table. I apologize. Hopefully it'll make more sense with the video once I get going here. So it says Laura is playing a game and rolling 2 6-sided dice. She wonders what the probability will be that the combination of the 2 dice will equal 10 or more. So we're going to try to look at the probability of getting 10 or more when I roll 2 dice. I'm going to use color here to show the 2 different dice. So again, the outside of the table are my 2 separate events, right? So in this case, what are the 2 events? Well, we have 2 6-sided dice that we're rolling. So the 2 events are the first dice and the second dice. And even though the 2 dice are rolled at the same time, we could still think of them as like die 1 and die 2. So the outcomes for the first dice, it's 6-sided, so there's 6 outcomes. You can get a 1, a 2, a 3, a 4, a 5, and a 6. And this is why I didn't really need this part of my table, so you could just kind of ignore that. The second die is going to go over here. Again, there's the same outcomes. They're 1, 2, 3, 4, 5, 6. And this is the one that always throws off students when we're in class, is that the inside of this table, you could write 1, 1 here to show that you got a 1. But since the question that we're interested in is actually about the sum of the 2 numbers, right? We want to know if we're going to get 10 or more. We are going to go ahead and put just the sums inside the table. Here, I'll use green for this part. So I'm just going to combine the 2 die that I rolled. I'm going to add these together for my sum here. So if I roll a 1 and a 1, I get a 2. If I roll a 2 and a 1, I get a 3. 3 and a 1, I get a 4. 4 and a 1, I get a 5, right? You might be noticing a pattern here because each of these we're just adding 1. Here, 1 and a 2 makes it a 3. You can actually see a similar pattern coming down this way. So 3 and 1 would be 4. 1 and 4 would be 5. Again, I'm just adding together the 2 die outcomes out here. This would be 6. This would be 7. And I don't know if you're starting to notice a pattern here, but on the inside of the table, again, these would just count up by 1. So it'd be 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9. This is 5, 6, 7, 8, 9, and 10. 5, 6, that's going to be 7, 8, 9, 10, and 11. And this last one here will go 8, 9, 10, 11, 12. And of course, 12 is the biggest number you can get with 2 6-sided die. So when I'm looking here for the probability of, what did I say, 10 or more? So probability of, I guess we could say greater than or equal to 10. A little shorthand for that. Again, you're just going to look on the inside of the table. So don't get confused with this one. Don't start looking at these numbers out here. That's why I color-coded them. These are just the individual dies. The outcomes are here on the inside. So how many total outcomes do I have? Well, there were 6 up here and 6 down here. So 6 times 6 is 36. There's 36 outcomes in here. And how many times did I get 10 or more? Well, you can actually find that down here in this corner. There's 1, 2, 3, 4, 5, 6. So we could say that the probability of getting a 10 or more is 6 out of 36, which actually simplifies to 1/6. And now I can find a lot of other probabilities here too. I could say, what's the probability I'll roll an even number? I count all the even numbers. I divide by 36. What's the probability I won't roll a 4? I count everything that's not a 4. But a probability table is a really nice way to see with 2 different events, all the outcomes, and then you can find the probability of any outcome in that table.